The next part of today's conversation is looking at KDB database design and scalability. KDB, again, extremely popular for any clients that need to capture large volumes of data. We essentially build systems that can scale anywhere from tens of gigs of data captured per day up to tens of terabytes or hundreds of terabytes of data coming into the system per day. KDB is used for holding data in memory. So let's say you have data contained in a process that you want to actually hold in RAM, which has various advantages like being faster to query. Can also be used to query data that's also contained within your storage, like on disk. So your process still runs within your server, but it reaches to the on-disk location to pull the data into the process for, again, applying computation. And then we have the streaming queries. So as the live stream of messages comes through, you can actually define specific actions or aggregations or various streaming analytics to that incoming live stream of data. And essentially between those processes, you can build up your end-to-end application. That's the beauty and the power of KDB. And that's what's being used under the covers with the application that's Insights Enterprise. So KDB is a vector-oriented columnar database. Okay, so we'll go through this in just a second, but essentially in a columnar database, every column is contained as its own file. And that actually gives you extreme performance benefits, especially for that on-disk data analysis. And then the vector-oriented nature gives you extreme performance benefits when you need to loop through data. So if you were writing Python, for example, you might have to apply a for loop as part of your code. Within a vector-oriented database, this is actually able to apply a function to that actual vector of data itself, so that column of data, and do all of that calculation all at once. So quite different to the likes of Python as a programming language, for example, which really does give very good levels of performance. Important to note, the analytics themselves happen where the data resides. So earlier I brought up that picture where you had different technologies all together, and you're having to extract data from one system into another in order to do your data manipulation. Well, with KDB, you don't need to do that. The actual functions, if you want to query the data that's held in memory, well, the queue process that is essentially holding that data in memory is the process which will perform the calculation using your function which you define. And the same goes for the on-disk, and the same goes for the streaming, which means for any action or custom code that you want to run, it is running where the data set is actually residing, which means you don't need to pull data across, lengthy IPC or across networks in order to get into something else to do that data. KDB itself has its own programming language called Q. It's a rich and functional language, and within Insights Enterprise, it's pretty much optional to use. But one of the key advantages for that language is its inbuilt functions that are used for data joins or temporal data analysis. That is really where KDB as a time series database will blow pretty much any other database in the world out of the water. And again, we'll come to that in a couple of moments. We have a very small memory footprint. It's around 800 kilobytes in size, and that means just accessing the programming language itself is extremely fast, much faster than many of our other competitors like Influx, for example, when it comes to simply calling upon the functions within the language. Now, if you're looking at microseconds or milliseconds, why is that important? Well, when you're streaming data and you're streaming data at, like, let's say 30,000 messages per second, microseconds and milliseconds really do matter. And that allows us to get incredible levels of throughput through those CEP engines that our other competitors cannot compete with.